All right, for the second part of the test, first couple questions you're going to be asked to do would convert from degrees, minutes, and seconds to decimal form, and then also from decimal form to degrees, minutes, and seconds. If you just go through and use your calculator, it's 23 plus 15 divided by 60 plus 18 divided by 3600. And you get your answer of 23.255 degrees. Because you just take that and divide it by 60 and that by 3600. If you want to use your calculator to have that do all the calculations for you, you can enter this as 23 and go into angle, put the angle symbol, 15, go back into angle, and push the second to get the minutes, and then 18. Now when you do the seconds, you have to hit the alpha button and the plus sign. And then you get 23.255 as well. Now those of you with a Casio, you need to go into the angle, and one of the choices has an angle symbol and a bunch of little lines. That's the one you need to use when you're putting in the different parts of this. So you push 23 and put this angle symbol or the degree symbol, not the first one. And then put 15 and hit that same button, and then 18 and hit the same button. So all these degree symbols are the same looking. And then when you push the enter button, it will convert it to 23.255. Now then, converting back the other way, again, if you want to do it the math way, you know it's 18 degrees. You take the decimal part of it and multiply it by 60, get an answer, and then again you take the decimal part of it and multiply it by 60 again, and then this would be your seconds, this would be the minutes. Or if you want to use your calculator, you just put in 18.72 and then you push second, angle, and number 4 DMS, and hit enter, and it will give it to you as 18 degrees 43 minutes 12 seconds. Now those of you with a Casio, you do the same thing. You'd put in 18.72 and then use this degree symbol again, and then you should get another one after you push the enter button, and it will have a line over the top of it, and then when you push that F button, you will get these values. All right, moving on to the next part. Secant of 210 degrees, depending on the way your calculator is set up. For those of you with a TI, check the mode. It's in radian mode right now, and you can leave it in radian mode or you can switch it over to degree. You may have to switch it back and forth if you're going to go to degree, so you might want to just leave it in radians for now. Those of you that have a Casio, you would push your shift button and set up once you're in the run part of it, and then somewhere on that screen it should say angle, and it's either then your choices at the bottom of the screen when you get down to angle are going to say degree and radian. Okay, so let's leave it in radian mode, and we want to do secant of 210. So therefore that is cosine, so we put cosine of 210 degrees. And we've got to put the degree symbol since we're in radian mode, enclose it in parentheses, and hit enter. And you get a negative 0.86602, and so on and so forth. And so now that's cosine. We're looking for secant, so we have to do the reciprocal of that. So you would want to use the x to the -1 button. On a TI, it is right here. On a Casio, I think it's the shift of something in by the parenthesis. So you just hit x to the -1 and enter, and you get a -1.15. And then this last question says, what's tangent of 7? Well, now that's a radian because there is no degree symbol after it, so then all you do is push tangent and 7 and close it and hit enter, and you get 0.8714. All right, moving on. Looking at some graphs of things. Anytime you're going to graph them, you should define everything so that way at least you can get some points for it if you're not sure on how to graph it. So we have an amplitude, and in this case the amplitude is 2. Period. Because it is cosine, it's 2 pi times the reciprocal of what's with the x, which is 1/2, and the reciprocal of a half is 2. So our period is 4 pi. Shift is going to be to the left because it's the opposite of what's there. And since our x is by itself inside the parentheses, it is going to be the left pi over 3. And finally, we have a shift down 2. And so this is going to be our midline, because it's down 2. Our maximum is up 2 from there and down 2 from there, because that's what our amplitude is. And since our period is 4 pi, let's go out to here, be pi and 2 pi and 3 pi. That scale is completely up to you as far as how you want to do that. And actually, that's probably not even a good use of our scale because we have to shift it pi over 3. So we want to have at least the third mark out, or the sixth mark out be pi. So we're going to go to the third. So there's pi and 2 pi and 3 pi and 4 pi. And same on this side. All right, that's better because we have this shift of pi over 3, so it's good to mark it in 3s. And finally, we have to deal with the shift, but let's see the cosine. Cosine starts at its maximum, which is here. But now we have to shift it to the left pi over 3, so that is going to start it there. And cosine completes a full cycle and it ends at its maximum. Now our period is 4 pi, which is 3, 6, 9, 12 marks away on our scale. So from our point we already have here, we need to go 12 marks away, which is right there. That's one cycle of it. Then halfway in between these two places, which is 6 marks away, it should be down at its minimum. And halfway in between the minimum and the maximum, it should be at its midline. And same thing on this side, it should be at its midline. Now that we have one cycle drawn, we can complete the rest of it. And there we have cosine. Drawn. Moving on to our next one. It's a -3 cosecant 2x minus pi plus 5. So, period. Or no, let's go amplitude first. Amplitude is 3, but because it's negative, remember it has to start at the opposite end of it, or going down if it's sine. Period is going to be 2 pi multiplied by the reciprocal of what's with the x, multiplied by the x, and that's a 2, so we're going to 2 pi times a half, which is pi for a period. Shifts is going to be to the right because it's positive. And now we have to get the 2 out of there because we always figure out the right and left shift when x is by itself. It is not at this point in time, so we have to divide that by 2. And if we divide this by 2, we also divide pi by 2, so it is going to be to the right, pi over 2. and then it is up 5. So our midline is 5 up. Our amplitude is 3 from there, so we go up 3 and down 3 from that point. And now we can start to sketch our graph, but now we are drawing cosecant, which is the reciprocal of sine. Sine usually starts in the middle, which would be there. But we must shift it to the right pi over 2. So we better first figure out our scale. And since we have to go to the right pi over 2, we are going to make the fourth line out pi, and 2 pi, and 3 pi. And so, getting back to this, sine usually starts in the middle, but we have to shift it to the right pi over 2, which is going to put it right there. And because it is sine, it starts in the middle and it ends in the middle, and the period is pi, so 4 marks is pi, so 1, 2, 3, 4 is where it ends. Halfway in between these two, it is going to be back in the middle. Halfway in between these two, it usually goes to its maximum, but because our amplitude has a negative value in front of it, it goes to the minimum at this point. And then halfway in between these 2 points, it goes to its maximum. And now we can complete all of our coordinates that we know of. And so on and so forth. And then, because we are doing cosecant, we are going to have asymptotes, and the asymptotes are at the midline. Due to time constraints, I drew in the rest of the asymptotes, and now we would have our function. And when you do this on the test on Friday, you need to make sure that you fill the coordinate plane completely from one end to the other. And there you have a -3 cosecant 2x minus pi plus 5. Moving on to our last example. Amplitude is 4, which, because it's cotangent, really isn't an amplitude. It just tells you the stretching up and down. Period in this case is going to be pi times whatever is with the x, so pi times 1/2, which is going to be pi over 2. And the reason it's pi is because cotangent and tangents periods are pi. Right and left shift is going to be right this time. And because we have to divide this by 2, we also have to divide that by 2, because we have to get x singular to figure out our shifting. And pi over 2 divided by 2 is pi over 4. And then we have a shift of up 1. And so here is our midline. And we are dealing with cotangent. And remember now, cotangent has an asymptote on the midline. Not on the midline, on the y-axis. Except in this case, we have to shift everything to the right pi over 4. So therefore, we first need to mark out where our scale is going to be. And so we'll go to the fourth one out again and make that pi, and 2 pi, and 3 pi. And now because this asymptote has to be shifted to the right pi over 4, it would be there. And then, looking at it, our period is pi over 2. So then that means pi over 2, there's our next asymptote. And the next one after that is going to be 2 away also. And 2 more, and so on, and so forth. And they have to go in both directions. And so we have a really narrow opening for cotangent. And since our midline is here, halfway in between is where we're going to have points shifted up 1. And halfway in between here and our asymptote, we have to be 4 away. And cotangent is going to be down 4 on the right side and up 4 on the left side. And so one cycle looks like this. If it were tangent, it would be the other way around. It would come up through here. And then you have to continue that throughout the whole thing. And there you have cotangent drawn for this particular function for cotangent 2x minus pi over 2 plus 1. Moving on to our next example here, we have to come up with an equation for this one. And because it is this wave that is going like so, we can either use cosine or sine. Which one you use all depends on how you feel and what you are looking at. First thing you want to locate would be the maximum, which is here, and the minimum, which is here. And figuring out the distance between the two. 2, 3, 4. It is 10 total, which means the halfway point is going to be 5 away. So right here is your midline. That is your shift up or down. And in this case, it is down 3. So we know we have to have a minus 3 at the end. Now, because it is 5 up and 5 down, that puts our amplitude at 5. It could be positive, could be negative, depending on which you use and how you use it. For now, we'll just leave a 5 there. Then we should figure out the period, which is from here to there. Counting, it's 1, 2, 3, 4, 5, 7, 8. It is 8. Pi is only 4, so it's going to be 8 pi over 4, which is the same as 2 pi. And cosine or sine has a period of 2 pi, so 2 pi times what gets you 2 pi? That would be 1. So when we put our cosine or sine, it is just plain x. And then finally, we have to figure out which do we want to use, cosine or sine. First, we will try cosine. Cosine is supposed to start its maximum, so we can use this as our starting point or that as our starting point. Could also use this, then you just have to make cosine negative, or the amplitude negative. But for now, we're going to use this one. And so it is cosine of x, and it is shifted to the left 1 mark, which is 4 there, so it's going to be left pi over 4, which means when we put it into the equation, it's going to be plus pi over 4. And then we're done. If you chose to use this mark down here, then you would have a -5 cosine x minus, and now that is shifted to the right, 3 pi over 4, and still minus 3. Now then, if you choose the sine function instead, sine starts in the middle, and if we use that point, then again it would be a -5 because it's going down first. And it's shifted to the right, pi over 4, so it would be x minus pi over 4 and minus 3. If you didn't want to have a negative amplitude, you would use that point or that one. We're going to use this one here on the left, so then we would have 5 sine x, and it's shifted 1, 2, 3 to the left, so plus 3 pi over 4 minus 3. And these are some of the choices you have to write that particular equation. Moving on to the next one. Again, first figure out where your top and bottom are at. Maximum or minimum are there and there. They are 1, 2, 3, 4 away, which means that the middle is 2 away, which is right there. So we have plus 1. Because we are dealing with these U-shaped things, it is either cosecant or secant. Since the middle is there, our amplitude is 2 away, so we know we have to have a 2. Then if we just draw in, we have this point and this point. Our period is from there to there, or from there to there, however you want to look at it. And it is 1, 2, 3, 4, 5, 6, 7, 8 marks. This case, pi is 6, so it's 8 pi over 6, which is the same as 4 pi over 3 for a period. So then to figure out what the value is, 2 pi times what is equal to 4 pi over 3? Well, if you take and divide by 2 pi, multiply by 1 over 2 pi, x is going to equal 2/3. And so when you put it into the equation, it is 3/2. And here's where you want to put the 3/2 outside of it and then figure out your shifting. So if we sketch this in here, between these, halfway in between here and there, it should cross the middle. So right there, halfway in between, it crosses the middle. And so you're looking at this function. All right, so now we have to decide what are we going to use, cosecant or secant. If we choose to start at this point right here, that's starting at the maximum, which is cosine, so that would be secant. And secant is shifted to the left, pi over 6, so x plus pi over 6 would be a good choice. If you went to this coordinate and started, then because it's starting downward, you would have a -2 cosecant 3/2 plus 1, and now that is shifted to the right, pi over 6, so x minus pi over 6. If you went to that point, then you would have, leave it as 2 cosecant 3/2, and x, it's 3 to the left, so 3 pi over 6 would be the same as pi over 2 plus 1. And I suppose if you really wanted to, you could even use this coordinate here. That would be a -2 secant 3/2 and x minus pi over 2 plus 1. Okay, then moving on to our last one looking like this. Here we have the wave, and so that is cotangent or tangent. Now the way that it looks like you'd want to use tangent, but again, you're going to have to figure that out as you go. graphs are just a little bit off, but here is those are our coordinates. Asymptote is here and here and there. So we know first off that our midline is in this location, which is up 1, so we have a +1 at the end. Then because we have an asymptote at this spot, and here is our asymptote, that is 1, 2, 3, 4, 5, 6 pi over 4, which is the same as 3 pi over 2. And so then to figure out the value we have to put with it, we use pi times what value is equal to 3 pi over 2. And x would have to be 3/2. When you put it into the equation, though, you flip it to make it 2/3. Now then, if you look halfway in between this mark and this mark, which is right here, how much is it up? Well, it looks like it's up 1, so there is no amplitude to this. It would have to be up in here somewhere and look like that to be up 3. And then you would put a 3 out in front. But in this case, halfway in between, it's 1. And so now, got to figure out which one you want to use. If we say tangent, tangent looks like this. Tangent's supposed to start in the middle here. It, though, is shifted to the right 1 pi over 4, so 2/3 times x minus pi over 4 would be a good choice. If you chose to use cotangent, that would all stay the same. Cotangent is supposed to have an asymptote here, and it doesn't. It is shifted back 2 to the left, which is pi over 2. And cotangent is supposed to go this way, so then we would have to put a negative out in front of it. And that concludes that one. Now on to these story problems. In this first one, you have a plane that is at 37,000 feet altitude. And it's flying, and up ahead, it spots 2 cities. One of them has an angle of depression of 76 degrees, which the angle of depression is from the horizon down, so this is 76 degrees, which is the same as your angle of elevation. The other one is out here, and it has an angle of depression of 32 degrees, which is also the angle of elevation. You are trying to find the distance from one city to the other. So we are going to have to do 2 separate problems here. First, figure out this distance. We will call it x. And we will also have to figure out this distance, which we will call y. And so let's figure out the long one first. And we have this angle. We know this side. We're trying to find y. So that's tangent of 32 degrees is equal to 37,000 divided by y. So solving for y, multiply both sides and get y equals 37,000 divided by tangent of 32 degrees. And that is 59,212.37. To do x, it's the same thing. Tangent of 76 degrees is equal to 37,000 over x. multiply by x, and then divide by tangent to get x equals 37,000 divided by tangent 76. And when you do that, you will get 9,225.14. And now all you have to do to figure out what the distance between the two cities is, here to there, is take these two things and subtract them. And you will get 49,987 feet, which is about 9.4 miles. Because you divide that by 5,280. If you leave 49,987 feet, I would be fine with that. Moving on to our next question here. And there's a little typo. This is walking 160 feet, and we're going to make this 110 feet. So here's a person standing here. They walk north 160 feet, and they go that way 110. Question says, what bearing should be taken to walk back to the original point? So we're going to go from this point back to the original. So we're going to need to find this angle. Since we have 160 and 110, compared to this angle, that's opposite and adjacent. So you'd say tangent of theta is equal to 160 over 110. And then solving that, theta would be equal to inverse tangent of 160 divided by 110. Now in using your calculator, 160 divided by 110 gets you 1.45 repeated, and then you have to take the inverse tangent of your answer to get what the angle is. Remember now you're in radian mode, so we have a radian measure for an angle. We want to convert it to degrees, so now we multiply by 180, divide by pi, and you will get 55.5 degrees is your angle theta, approximately. Now, you have to do a bearing from here. So this angle is 55. A bearing has to deal with north and south, or west and east. And so we are going to go from here to here. The directions we have to travel are south and west. So if we're going to go south first, we're going to need this angle. Well, if we have 55.5 for this angle, this one is complementary to it. So that is going to be 34.5 degrees, and then west. If you wanted to choose to write it as west 55.5 south, you could also. How far away is the original point? Well, there you just use your Pythagorean theorem. Take the square root of 160 squared plus 110 squared. And that you will get approximately 194.16 feet. And that is this distance right here. Moving on to our next one. Plane takes off at 390 miles per hour and leaves a runway at an angle of elevation of 26 degrees. So that right there is 26 degrees. It is traveling at 390 miles per hour, and it's going to climb for 20 minutes. It wants to know the altitude, which would be that. And so we have the opposite side, and the hypotenuse, which is sine of 26 degrees, equals the opposite over the hypotenuse, which we need to figure out this distance. At 390 miles per hour for 20 minutes, you have to take 390 times 20 divided by 60, because there's 60 minutes in an hour. And this is in miles per hour. And when you do that, you will get 130 miles. So that becomes 130. Now to solve, you multiply 130 times sine of 26, and you will get 56.98 miles in the air. Probably not realistic, but for the purpose of this question, it'll have to do. Our last one, probably the most difficult one you'll see. It says two cameras that are 75 feet apart are focused on a bird's nest that is in a tree. The tree is between the two cameras. So we have a camera here and we have a camera there, and the tree is somewhere in here. And they're all in the same line. And up here is the bird's nest. It says that the angle of elevation from one camera is 14 degrees. So this one we will say here is 14 degrees. And the other angle of elevation is 34 degrees. That will be that one. We are trying to find how high it is to the nest. So that distance right there, that's a right angle. Now, you can't just find this directly because you know no other measurements other than this distance is 75 feet all the way from one end to the other. Well, if you look at the yellow triangle, you're trying to find x. If you have this 34-degree angle, you need to know this distance right here, which we do not know. So let's call this another variable. Let's call it a. And so then to figure this out, you would say tangent of 34 is equal to x over a. Now looking at the blue triangle, same thing. You know this angle. You are trying to find that side. We are going to need to know that one. Well, if this one is a, and this whole thing is 75, then from here to there, it is 75 minus a. And so in our other triangle, we would have tangent of 14 equals x over 75 minus a. Solving this for x, you would get x equals tangent of 34 degrees times a. Solving this for x, you would get x equals 75 minus a times tangent of 14. And now we have two equations that both have an x in them and both have an a in them. But we have x equals this and x equals that. And so now we can set those two things equal to each other. So tangent 34 times a equals, and this you can distribute, 75 times tangent of 14 minus tangent of 14 times a. Now, understanding that the tangent of 34 and the tangent of 14 are just numbers, and 75 times tangent of 14 is just a number as well. So if we're going to solve this for a, we got to get the a's to one side. We need to add tangent of 14 to this side. And so if we figure this out, we have tangent of 34 plus tangent of 14. So we need to go to our calculator. Tangent of 34 degrees plus tangent of 14 degrees equals 0.9238. So this is approximately 0.9238a equals 75 times tangent of 14 degrees. And then we have to divide that by 0.9238. And so then A is going to equal 75 times tangent of 14 degrees divided by the answer we just got. And X is going to equal 20.24 feet. And so now we know that this distance from here up to the bird's nest is 20.24. And that concludes this review for the second part of your test.